Hi everyone, this is video 13, and today we're going to be continuing our discussion of sequences and talk about strings, ranges, mutability, and dictionaries. But before I go into that, I want to talk a little bit about checking inclusion in sequences. This is actually a pretty simple syntax to do this. We just check if some particular name is in the sequence. And it allows an easy way to check if any particular element is in a list or a tuple. So let's just quickly see a demonstration of that. I'm going to start up Python. Let's say I have a list 1, 2, 3, and let's say I didn't know that this list had 1, 2, 3 in it, and I just want to check if 1 is in the list. Well, what I can do is I can just check 1 in the list, and that's true. Do I want to check if 10 is in the list? Obviously that's false, but is 10 not in the list? That would be true. So this is how we use the very simple in operator. So I think this is pretty intuitive, and before no time you'll get the hang of it. So now let's move on into the next topic, which is strings. Strings are a very, very important part of Python, and not just Python, but any programming language, because it's a representation of language, or it's a representation of data, or it can be a representation of programs themselves. So strings are very, very important. So let me just talk a little bit. So we've seen some strings here and there, but now let's go a little more in detail. We can define strings with single quotes, so I can have hello, or I can define them with double quotes. So one question you might be asking is, what's the difference? Well, generally, if I have strings with single quotes, I know there's no apostrophe in them. The only time I want to use double quotes is if there's an apostrophe. So like, if I have it's me, you know? So here there's an apostrophe. So the reason you don't want to use single quotes is the apostrophe can get confused for being the end of the string, and then you're going to have an error. So this is that type of syntax. And then what can we do with strings? Well, we can add them together. What does that do? It just combines the strings. It's a process called concatenation. And then, well, at the end of the day, strings are just special cases of sequences. So we can also do multiplication, and this will result in repetition. So this will create 2 copies of hello. So if I want to get 5 copies, I just do that. So pretty simple. Now, because strings are sequences, they also have a length. So if I want to find the length of hello, I know it's 5. And also spaces count as characters within a string. So the length of string 2 here, which is it's me, is going to be 8. Okay, so 1 space there, then 1, 2, 3, 4, so 4 plus 1, 5, 6, 7, 8. Looks right. Okay, so just don't be confused by that. Now, what can we also do with sequences? Well, we can select elements. So I want to select the 5th character. I have to go into the 4th index, and I know that's an O from my hello string. And then I can also do any type of list processing operations like list slicing. I can do that. So if I want to reverse a string, a good way to do that is just doing that special reverse syntax. So this is all it's very similar to strings. So just think of strings as a special case of a list. And in reality, a string is a special case of a list. Alright, now let's look at some problems on strings. So let's say I want to check if the first string, which is called sub, is a substring of the second string. What does that mean? Well, let's look at some examples. So I know race is included within race car because race is this and it's shown right there. Okay? And noon is also a part of afternoon, as you can see. It's right here. Okay? Now, here is also part of where's my food. So here is right there. So this is our basic goal here. We want to see if something is a substring of another. And obviously YOLO and death have nothing to do with each other. Literally and figuratively, because YOLO is not part of death. And, okay, never mind. Bad joke. But anyway, so because a string is a sequence, it allows things to be very easy for us, because how do we check inclusion in sequences? Well, we use the in operator. So we can just check if sub is in the string, and this is going to give us our Boolean expression. So let's just test this out. And it works. Okay, so that's how we do that. And then the next question we have is another pretty simple one. We just check if the string is a palindrome. So race car is a palindrome because it's the same forwards and backwards. Tent is obviously not a palindrome. So because we can use the same ideas of a list, how do we reverse a list? Well, that's just this special notation, and the definition of the palindrome is that the reverse of it is equal to itself. So we just check that. Alright, so this will also work. Alright, so now this next problem now is a little more tricky. So I threw in some 2 easy problems, but now this one's a pretty hard problem. So take some time to see if you can figure out this. Basically, we want to return true if a string has repeated characters and false otherwise. And there are many ways to do this, but I'm going to use a recursive approach. Yes, recursion does come back, so don't forget it. So the way I'm going to think about this is, well, first I'm going to think about my base case. What's a case where I know there's not going to be any repeated characters? If my string has length 1. So if my length of my string is less than or equal to 1, I know for sure that this is going to be false, because there's not going to be any repeated characters. You can only have a repetition if there's at least two characters in the string. Okay? So, what do we do now? Well, what we can do is we can check every character in the string. Okay? And what we want to do is we want to pick out the first character. Why the first character? Because let's think about how I would check if something was repeated, if I was going to brute force this, basically. Well, first I'd take H and check if everything else had any H, and then I'd check E, and then I'd do the same process. I check if everything else had an E. Why do I not need to check H? Well, because I already checked H and E in the previous case. So this is the basic idea we're going to have. We're going to pick out the first one each time. So the first one initially is going to be U, and I'm going to check, hey, is there any other U here? And there is, so I know this is true. And in the case of hello, when I get to my pivot, which is L, I'm going to find that there's another L. And so basically, the point here is we're going to define a pivot. And the pivot is going to be the first letter in the string initially. Okay, and then what I'm going to do is I want to iterate through the rest of the string. How do I do that? Well, I can use slicing notation. I can go through the rest of the string, and if my character is equal to the pivot, I know immediately I have a repeat. Okay? And then if this is not the case, then I know in the first try, when I checked H with everything else, there was no other H, so I then need to move on to the next character. And then when you move on into the next character, you're really going into simpler subproblems of this. So I can do this recursively. I can just check if there's any check repeated on the rest of the string. So, and then if we look at the recursive leap of faith, we first check the repeated initially, and then we do the same process on the rest of the string, and we know for sure that we just went through the entire string to see if there is any repeats. Alright, so this is going to work. Let's just test it just to make sure, and it works. So this is pretty hard to see though, so don't feel bad about this one. This was a more tricky problem. But one thing I do want to emphasize is that it's super, super important that you stay up to date with recursion, especially we're going to be soon moving on into new topics that will rely heavily on recursion. So make sure you feel very comfortable with this type of recursion.